Assalamu alaikum. Sorry guys, I missed another part. Okay, the second part is about differentiation. Or now it's called calculus in the new syllabus, or in the updated syllabus in Cambridge. They call it calculus. If you remember guys, in another video I explained the idea of this, why we get the derivative. I hope that you still remember so you can understand. First part is done by Mus'ab and is correct. How to get the dy over dx. To get the dy over dx, for those who don't remember, what we do is, for example, if y equals a x power n, so when you do dy over dx, what you do is you drop the power and you multiply by a, so it will be an, and then x power n minus 1, and then you subtract 1 from the power. So let's do this here now. So y equal x cubed, so dy over dx, it will be x cubed, drop the 3, the cubed, it will be 3x, subtract 1, it will be 2, minus, drop the 2, 2 times 2 is going to be 4, 4x, and 2 minus 1, it will be 1. You don't need to write 1, minus, and here is already x power 1. So when you drop it on, it's still 15. And then it will be x power 0, which is 1. So that's it. 3x squared minus 4x minus 15. Okay. He say C, it looks like here is C, but it's not clear. C is the curve with the equation yx equal x cubed minus 2x cubed minus 15x. Okay guys, you have to know that any cubic graph, how I know it's cube, it has the highest power is cubed. So here the equation is y equal x cubed minus 2x squared minus 15x plus 5. As you see, the highest power is cubed. That means the function, it's either this way or this way. Okay, it's from the right to the left or from the left to the right. How I know it's this one or this one? It depends on the coefficient of x cubed, the leading coefficient. Well, the leading coefficient here is 1. It's positive, so it's this way. If it's negative, it will be this way. So our curve is going to be this. Looks like this. He's asking now, work out the range of values of x which has a negative gradient. Negative. The gradient will be negative if it's decreasing from left to right. If it's increasing, like here, look here, it's increasing. Look here also, it's increasing, but here is decreasing. Here is decreasing at this part. So this part, the gradient here is negative. But here and here is positive. Again. As you remember guys, if the line is increasing, we call it positive gradient. We say that this line has positive gradient. If it's decreasing from left to right, decreasing, we call it has a negative gradient. Now, if you remember, I explained this idea before of why we do the derivative, why we get the derivative. If I wanted the gradient at this point, what I will do? If I want a gradient at this point, I'm going to draw a tangent that goes through this point, and then I will assign 2 points on the line, on the tangent, then I got rise over run. Rise over run. That's the old way. This way is accurate, not accurate. It gives me approximately a correct gradient. Approximately. About. Not accurate. How I get accurate? We use derivative. So if I get dy over dx, I'll get the equation, the accurate equation of the gradient at any point on this curve. So if I want to get the gradient, the accurate gradient at any point at this curve, maybe here, I can use this equation. Which equation? That we just got it now. dy over dx. That gives me the equation of the gradient. The equation of the gradient. So 3x squared minus 3x squared minus 4x minus 15. This is the equation of the gradient. dy over dx. Right. Now, as I told you, this any point on this part. Again, let me just clear this, because this part of differentiation and the curve lines and the gradient needs someone that understand, not someone that memorize. If you memorize, you'll get deceived, you'll get tricked by this type of questions. Look, small change in the questions makes a big difference, makes you get confused. If you don't focus on the concept, if you don't have a critical thinking, you have to focus on the concept, what I'm doing, why I'm doing it. So again, this should be, sorry, it's not that accurate. The curve should be in this form. Okay? If I want to get the gradient at any point on this curve, I'll use this equation. Right. Which part I'm looking for now? I'm looking for the part that will give me negative gradient. I need negative gradient. Where is this gonna happen? This is gonna happen here. Only here. At any point between the minimum and the maximum. Any point here is gonna be negative. It's gonna give me a negative gradient. Why? Because the tangent is gonna be looking this way. It's gonna be decreasing. It's gonna be decreasing from up all the way down. So any tangent here will be negative, will have a negative gradient. So how can I get the range of the points between here and here? I need all these points, because any point here is a negative gradient. How I get it? If you know that this point is, if they know that these points are the turning points, these are the turning points. Turning points. Sorry, spelling is wrong. Here and here we call them turning points. Why? Because the curve line got a change from up to down or from down to up. At the maximum point here, it was increasing, then decreasing. At this point here, it was decreasing, then increasing. Also, we call them stationary point. Stationary point. Why is it called stationary points? Because it's like a stop. At this point, the curve stops from increasing, then starts to decrease. It's like a break. Okay? So if you get these 2 points, any points in between, we will have negative gradient. So I need to get the turning points. How we get the turning point? At the turning point, dy over dx equals 0. Why? Because any tangent at this point will be horizontal line. Look, if I draw a line here, it's going to be horizontal. What the gradient What the gradient of horizontal line? 0. So now the dy over dx of turning points is always equal 0. So I'm going to get the turning points, and then the points in between will be the point that has the gradient negative. So 0. What's wrong? Okay, so 3x squared minus 4x minus 15 equals 0. Then I think I explained how we factorize quadratic equation when the coefficient is not 1. It's more than 1 or less than 1. It doesn't matter. So quickly I'll do it now. So it will be negative 45. What times what equal negative 45? And when you add them, you get negative 4. It's going to be negative 9, positive 5. And then I'm going now to break it apart. So it will be 3x squared minus 9x minus, plus 5x minus 15 equals 0. So what I did now, is changing this to this to make it 9x plus 5x. Negative 9x plus 5x. Why? Because this gives me negative 4x. Why I'm doing this? So I can factorize. Because I can factorize by the normal way. For sure there is other way, but I prefer this way. This way is really easy. So what I do now is factorizing by grouping. I take this group together and this group together. So 3x is common factor here. It will be x minus 3. And 5 common factor here, it will be x minus 3. As you see, after factorizing by grouping, you always get two brackets are the same. So I'll take these brackets as a common factor again. So x minus 3 times, so this is gonna be done, then it will be 3x plus 5 equals 0. And then x minus 3 equals 0. X minus 3 equals 0. That means x equals 3. X equals 3, or 3x plus 5 equals 0. Subtract 5, then divide by 3. Yeah, and there is no time to do this, so negative 5 over 3. That's it. So it doesn't matter now which one of them is the minimum and which one of them is the maximum. It doesn't matter. Why? Because I need the values in between. I need the range in values. I need, guys, the range of x that has negative gradient. So any value in between. So the range of value x more than negative 5 over 3 and x less than 3. Any value between these two, points, these two turning points, is going to be negative gradient. And that's the solution now. So the answer is x is greater than negative 5 over 3 but less than 3. Very long video, but what can I do? If it's not like that, you don't understand. Okay, thank you guys.